Hello and welcome to the fifth in a series of videos on systems thinking. My name is Bhaskaran and I am the faculty walking you through this series. In this video, we are going to try and understand how people solve problems and the role of mental models in such solutions. I am sure you have wondered why it seems very easy for you to solve a problem in a specific situation and yet so difficult for you to solve a different problem in a different situation. Mental model is the answer. Mental model is actually very useful for us to make sense of the world. The world is extremely complex and we as human beings need to simplify this, need to understand this to make sense of it. And each one of us understands this world from our own perspective. So understanding your mental model and understanding other people's mental model is a good way to understand how you and others solve problems. So my objective in this video is to try and help you understand how and describe how people solve problems, is to try and explain the role of mental models in solving problems and difference between traditional and systems thinking. So let's look at how people solve problems, what are the kinds of problems, and how would you apply yourself to these problems. There are typically four kinds of problems. The easiest is called the simple problem. In a simple problem, the cause-effect relationship is understood. So for example, if I am driving, I see a target in front of me, I apply the brakes. So I see another car in front of me, I apply the brakes. The cause is the fact that there was a car in front of me, the effect is that I apply the brakes. This is a simple situation. In simple situations, you sense the world, in this case the car, you categorize it mentally, internally within yourself and you say, hey, I've got an impediment in front of me, if there is an impediment I must slow down, and that is the response. So sensing, categorizing and responding are the ways you would solve simple problems. Standard operating procedures is what makes this happen in an organization. You also share best practices to solve simple problems. The second category of problems is what's called the chaotic problem. It's incoherent. A chaotic problem is characterized by its incoherence. Cause-effect relationships are not directly perceivable. So for example, I may have a fever. Now was this fever because I took an ice cream last night, or because I exposed myself to the rain, or because I did not dry my hair in the morning after a bath? The cause-effect relationship is not very obvious in these circumstances. And typically the way you would resolve a chaotic problem is to somehow bring order out of chaos. That means to bring stability into an unstable situation. So in this case, when I have a fever, the first thing I do is to take some medicine to reduce my fever. I'm trying to bring the human body back to its stable condition. So first of all, you act, then you sense what happens, and then you respond. This is how people manage chaotic situations. All stability focused interventions come under this category of crisis management. The third category of problems is what's called complex problems. In a complex problem, it is retrospective. Over a period of many iterations, you reach coherence. So cause-effect relationships are not really repeatable. In the world of software, you call these random defects, because when the system is running, apparently it runs well, and suddenly up pops a bug. So you need to understand that this kind of situation is not amenable to the routine cause-effect kind of solutions. In this case, you try to establish a pattern. When you have a random set of defects occurring, you try to establish a pattern. And this is really pattern management becomes this source of the solution. You do a lot of experiments to establish that pattern. So in this case, you probe, you sense, and then you respond. The last category of problems is what's called the complicated problem. In a complicated problem, in difference to a complex problem, the solution is potentially knowable. You understand, you think you understand the solution. The beauty of this kind of situation is that the cause and the effect could potentially be separated either in space or in time or both. So something that happened in the past could impact you today, or something that happened in another location could impact you today. Here you use a lot of expert judgment. In one of our further videos, you will understand the need and the role that experience plays in systems thinking. Expert judgment is exceedingly important to solve complicated problems. You kind of do scenario planning, so you look at all kinds of conditions that could have led to the situation as it exists now, and then you try to analyze and resolve the situation. Here you sense, you analyze, and then you respond. So these are the 4 large categories of problems as we understand. Now let's look at the role of mental models in problem solving. Understand this, every one of us carries a mental model. It doesn't matter what profession you are in, it doesn't matter what qualification you carry, it doesn't matter how much experience you have, you will carry a mental model. Now, mental model can be a boon, it could be a bane. It could help you resolve a problem, it could prevent you from resolving a problem. So let's look at how mental models evolve. First of all, you observe the world. When you observe the world, you do not take the world in, you do not take all that information in without filtering it. You will filter whatever data that you have seen, and you will learn from that filtered data. So already your impression of the world is not perfect. Now the fact that I filter the data differently from the way that you would filter the data already contributes to differing mental models. Based on the data that I have filtered and absorbed, I now create a meaning. That meaning in turn leads to assumptions, and those assumptions help me draw conclusions about what I have seen. Based on these conclusions, I create a belief system of the world, and ultimately I take actions based on those beliefs. This is the reason why each one of us carries a different view, a different perspective, a different model of the world around us. This was first enunciated by Peter Senge in his classic, The Fifth Discipline. And he explains in great detail how each of these steps contributes towards us creating unique mental models. Let us now move on and try to understand the difference between traditional and systems thinking and how they relate to this concept of mental models and the kind of problems that we have been talking about. The primary difference can be seen from this diagram. Anybody who has ever solved any problem knows what a fishbone diagram is, and this is an example of a fishbone diagram. In this diagram, we are looking at studying how to resolve quality issues of a product. Now, if you were to do analytical thinking, you would break it down and you would say, you know what, the quality of a product can be defined by the experience of the team members. So the more the experience of the team members, the better the quality. We could talk about the morale of the team members. If they have a high morale, that means they're motivated, they're energetic, they want to do good, and therefore the quality will be much better. You could say, you know what, if I had large attrition in my team, then I keep bringing in new people into the team, they don't understand the system, quality of the product would be less. And this is the way you would analyze a situation in traditional analytical thinking. If you were to move on and think about this from a systems perspective, you would understand that each of the 6 bones that we spoke of in the earlier diagram are really related to each other. Attrition is related to morale of the team. Experience is related to attrition. The pressure on quality defines fatigue. The higher the pressure on quality, the more fatigued the team members would be, so on and so forth. So suddenly, rather than looking at each of these contributing factors as individual independent contributing factors, we see them as a holistic system. And the fact that many of them interact with each other to create this final impression about the quality of the product. This suddenly converts your thinking from traditional analytical thinking to systems thinking. This brings us to the second classical definition of systems thinking. In this definition, it talks about developing a model which kind of defines events, patterns, or behaviors, which in turn results in events, and even more importantly, the underlying structure responsible for the patterns of behavior. Very complex, right? But this is systems thinking. Let's try and simplify this. So what we are really saying is, at the bottom, you remember that each one of us as human beings like to simplify the world. So we create a model of the situation, of the system. This model it comprises of a series of events, which in turn leads to the behavior, the patterns of behaviors of the system, which is defined by the underlying structure of the system. I'll give you an example that should make it easier to appreciate. Start at the top of this diagram. The event is that there are many products failing within the warranty period. This is what is the observable information from the environment. Products are failing within the warranty period. The underlying structure is, after a lot of analysis, we determine that parts below a specific price point are the ones contributing to this failure. So low cost parts are contributing to the failure of the entire system. And therefore, what do? Traditionally, we increase the testing of such components. Hopefully, by increased testing of these low cost parts, we eliminate the defective parts right in the beginning, and what actually gets built into the system is much more robust. But this leads to an unintended consequence. What you now see is parts continue to fail. But the reason now is a little different. Increased testing has put pressure on the cost of the product. The more you test, obviously, the more cost it is. And therefore, what do? You further reduce the cost of the parts. Reducing the cost of the parts further increases the pressure on testing, further increases the pressure on quality, and you enter a vicious cycle. You have to break this cycle somewhere to make it a virtuous cycle such that the whole system stops failing during the warranty period. This is the difference between analytical thinking and systems thinking. So remember, focus is on parts versus focus on the whole. In analytical thinking, you would focus on the parts. In systems thinking, you would focus on the whole. In analytical thinking, the focus is on objects, whereas in systems thinking, the focus is more than that, it is on the interaction between objects. In analytical thinking, it is kind of reductionist in nature. You break up a system into its components. In systems thinking, it is synthetic in nature. You build up a system from its subsystems. In analytical thinking, you traditionally do what's called root cause analysis. In systems thinking, you do multiple probabilistic causality analysis. Analytical thinking leads to a static solution, whereas in systems thinking, you come up with an adaptive model. An adaptive model that changes with time, that changes with events, that changes with the environment. And obviously, systems thinking then leads to a more permanent fix, a more long-lasting fix. A systems thinking solution, a systems thinking approach helps you understand all the subsystems and all the interactions between the subsystems, helping you achieve a much more robust solution. So in summary, this video has helped us understand how people resolve problems and the 4 kinds of problems. It helps us understand the role that mental models play in the way we solve our problems. It has helped us understand that each one of us has our own unique mental model. It helps us understand the difference between traditional analytical thinking and the more modern systems thinking. I hope it gave you a flavor of the complexity of the subject. As I said, this is an introduction into the field of systems thinking. I would urge you again to read a little bit more about the concept of mental models and the concept of systems thinking. Thank you very much.